Foreign key is important in what we call referential integrity. So referential integrity basically comes from outer join, the issue of outer join. Outer join has its own issue. First of all, when you do outer join, you know for sure that some rows from the outer join the table from the outer table does not have a matching record in the other table. So for this, there is a possibility of unknown result. You don't know how many rows are like not matching, but still get select. And for those outer join the rows, you will have null in those unmatched columns, right? So in those columns from another table in the unmatched rows. So you will have a nulls in these columns, and null handling is very error prone. There's a lot of issues with null handling, either in filtering condition or in processing or function processing. So also outer join, for outer join, you will have to go through all the data values. Because of this, a lot of optimization is not applicable when you are using outer join. So performance may be suffer a hit when you use outer join. And because of these reasons, usually you should avoid outer join whenever possible. Now, and it is true that outer joins a lot of times is required because you may have tables from different sources which you don't have control over. When you get the data comes in as is, not cleaned, not matched. You have to use an outer join in order to get a full picture, or in order to process everything, in order to not missing anything, right? But just because you can do it, and just because sometimes you need it, doesn't mean it's always a good solution. If possible, if you know your data that does not require outer join, try to avoid it. And better yet, if you can enforce some rules, you can even eliminate the need for outer join. And this enforcement comes from DBMS. So first of all, let's look at why we need outer join. Outer join is necessary when the columns joined, when the columns joined on have values that not existing in the corresponding columns in the other tables. The reason you want to do an outer join is because some values does not have matching values, right? That's the only reason. You know some values does not have matching values. That's why you need outer join. If every value from one column have corresponding value in another column, then there's no need, and vice versa, then there's no need to do outer join at all. You can eliminate the need for outer join. And this corresponding thing is called referential integrity. Referential integrity requires that if a value of one attribute of a relation references a value of another attribute, then the referenced value must exist. And the foreign key is used for this referential integrity. We already mentioned that the join key, the column you use to join, usually should be the primary key of one of the two tables. It's called a foreign key. So now that we know it's a primary key in one table, it should be unique. It should have all the values of that relation, right? So DBMS can use this foreign key as an indicator that you will need to apply a data integrity, referential integrity check on the data of these two columns. When you define a table, when you define a relation, you also define if this attribute, whether you will use this attribute to join another table or not. If you want to use this table to join another table, then that's when you need to apply referential integrity check. Make sure these two columns both have the values in another table. So foreign key by itself is a column constraint that once you defined, DBMS will define a restriction on data. Column in one table, the one that is not in the primary key, must have column in one table, the one that is the primary key must have all the values in the corresponding column in another table. So for example, instructor or course, instructor table have the instructor name as a primary key, and the core, every instructor in course must show up in the instructor table, right? So column in the instructor table, let me just highlight it. So the instructor name column in instructor table, which is the primary key, must have all the values in the instructor name of the course table, which means every instructor in course shows up in instructor table. So when you similarly, we have the products and the orders, right? As you can see, we have many different products, and we can have orders, and each order must be attached with a product number. So for products table, I have the primary key product number. And for orders table, I have the column called product number. Apparently, when I define this order table, I already know that I will join products table on this product number. So I define a foreign key, which is, this is syntax, references products product number, which means this table, this column is associated with the products product number column. And referencing this to the, every table, every data in this product number, orders product number column must exist in products, in the product number column of products table. It references there. Every data in the orders table must have a reference in the products table. This is what it means. And you can see that the product number here is surrounded by a parenthesis, which means if necessary, you can also define multiple columns here. And the combined value of the column will be the foreign key. So how does DBMS enforce this key violation? Enforce this foreign key constraint. So we already said every value in order table must be in the products table. So there's only two ways that it can be violated. One is if you are inserting a new value into orders table that is not in the products table. In this case, you will see an error. You are trying to insert the value into the referencing table that is not in the referenced table. The other way is if you want to delete a value from products table, you want to delete the table from the referenced table, which happens to have a reference. Then the referencing table, the order table, will say no. I have this value, and you cannot delete yours because I need to reference yours in order to satisfy the referential integrity check. So you must delete from orders first. You must delete everything with this product number from orders table before you can delete the products number from this product table. Now, Postgres also allows you to perform a cascade delete if you want to delete from product. So in this case, you will define the product as order table as product number in integer, which is the normal column definition. References, same way, product number. With one phrase, on delete cascade. That means when you delete product number from product, everything in the orders table will be deleted. Everything with that product number in the orders table will be deleted. Let's say I have a product number, Christmas tree, and now that now it's July 4th, I don't need that. I'm going to delete this product number. Then every transaction in the order table regarding the Christmas tree will be deleted. But then, just because you can do that doesn't mean it's a good solution. You usually try to avoid it because you may accidentally delete useful data. What if I want to keep this record for historical historical query, right? So usually be careful on this automated cascade things and try to avoid it unless you are very clear on what you want to do.